Hello. All right. What we're going to do here is I want to show you this chart. Now, where does this chart come from? So, in class, I showed this video, and you can YouTube this. This is Usain Bolt in 2016, and I'll spell that for you. Usain Bolt in the 2016 Olympics. So there's a technique that he uses. If you watch his video, what he does is he actually doesn't start out super fast. Oh, well, he does to us, right? But his competition is always ahead of him about halfway through the race. Now, I don't know the exact distances, so I've created a situation here that kind of illustrates it very generically. So down here, this is our time in seconds, and so at 1 second, 2 seconds, 3 seconds, it shows us where he is in time. This is our distance, this is how far he is. So at about 5 seconds, he's around 40 meters, and this is an estimation. It's probably not 100% legitimate, but this will help illustrate a point that you need to learn. Okay, so what we want to figure out here is we want to figure out how fast was he going right here, and how fast he was going right here. He starts out a little slower here than he does here. So the strategy here is if we can figure out how fast we need to be going, we might be able to surpass him here. Okay? But let's see how this works. So in order to figure out how fast someone goes, so you gotta think about it, like, how do you calculate somebody's speed? Let's break it down first by when you're in your car, what are you doing? You're going about 40 miles an hour. So we have miles per hour. All right, and we would write those units, miles per hour. We write it like this is a fraction. And what we see here is miles comes first, hour comes second, miles on top, hours on bottom. This is the distance in miles over the time in hours. And calculating speed is exactly like that. We're going to use distance divided by the amount of time it takes. So let's look here at this time right here. This time right here is approximately 5 seconds. Okay, so that would be the bottom part of our graph. So we have 5 seconds here. Well, how far did he go in 5 seconds? Well, we go from 0 to 40. So this is right here is about 40 meters. So we got about 40 meters in 5 seconds. So his total speed, if we simplify this, so 40 divided by 5, would be about 8 meters in 1 second. That's pretty fast. I don't know if I can go that fast. But that is his speed. All right, well, let's look at something else. What's his speed right here in the second section? Okay, so again, we're going to look at time, we're going to look at distance. And remember, distance is on top, and time is on the bottom of our fraction here. So I go from 5 seconds. Don't have another color. Wait, I got one way over here. So let's look at this here. We got 5 seconds right here. How do I know this is 5 seconds? I went from 5 to 10. All right, so let's see. I got 10 seconds minus 5 seconds. That gives me 5. So that's how I know it's 5 seconds. And that comes in. That's helpful in a moment, okay? Well, what's the distance? So let's see. We got 10 minus 5. That equals 5 seconds. All right, so right there. Okay, so let's come over here and find out the distance. So the distance here goes from 40 meters to 100 meters. So what's that distance? Let's see. That distance is going to be 100 meters minus 40 meters. Because this is where we're going and this is where we are. That's 60 meters, right? So he's going 60 meters every 5 seconds. All right? And if we simplify that, that's about 12. So 60 divided by 5, that's 12 meters in 1 second. So he goes from 8 meters a second to 12 meters a second. So he starts out at 8 meters a second, then he bursts up into about 12 meters a second for the last 60 yards. So these are very helpful. This gives me a comparison. So let's say I start the race and I'm going at about 11 meters a second, and I continue going 11 meters a second. Will I beat him? So that's where that information comes in handy. You do a little bit of analysis. It gives you kind of a goal when you're running, what you're aiming for, how fast you want to be going. Well, is there an easier way to figure this out instead of having to go through this difference of distance over difference of time? So let's see if we can simplify this a little bit more, okay? Because here I went from 0 to 5 seconds. Okay, so I could have honestly have said that down here, like I did here where I did 10 from 10 minus 5, I could have done 5 minus 0. That would have given me the 5 seconds. That's exactly what we did to try to figure that out. And over here, I went from 0 to 40, and that's how I got my 40 meters here. So there's a general formula, there's a methodology of trying to figure out that speed, and it goes like this. I find the difference in my y values. All right, those are the ones on top. That's my distance here. This is the y-axis. So I find the difference in the y values between the 2 points I'm interested in. All right, and I also find the difference in my x values, and that goes in the bottom. Now I put this x1 and x2 or y2 and y1 just to note that these are two different numbers. And I could have very well put y1, y2, x1, x2, but in textbooks and all over the place, you're going to see it like this. And I'll explain a little bit more when we go over some practice problems. But this right here, this rate of change, we call it the slope because it describes a linear function. Okay, so we call this the rate of change or the slope rate of change. And many graphs have a rate of change, but a linear graph, we call that slope. It's just like a nickname. Kind of like if I said I like chocolate, and this would be that category. It's a big category that talks about a lot of different equations. Slope would be like M&Ms. It's one candy that's chocolate in a whole bunch. All right. So slope describes linear equations. So this is my slope. So is there an easier way to find it? Well, sure there is. So check this out. What if I created a chart? All right, like an XY chart, kind of like you're used to. Let's do. This is seconds, and this is meters, right? So at 0 seconds, he was at 0 meters. That's pretty apparent. 1 second, he was about 8, and I'm going to give this to you. He was about 8 meters. 2 seconds, he was 16 meters. 3 seconds, he was 24 meters. Now remember when we were looking at patterns, right? Look down this right side. If we're trying to create an equation, like, okay, if he kept going, where would he be at n seconds? 0 to 8, that's adding 8. 8 to 16, that's adding 8. 16 to 24, that's adding 8. All right? And so we have a pattern of adding 8 here. And when we were drawing our equations, we would say, all right, that's 8 times n, all right, so far. But do we add anything? Well, at the 0 second mark, he was at 0, so we would add 0, which doesn't do much. So that's 8 times n. That's our pattern. This 8 here is our slope. That's not coincidence, okay? So if we're going across, 1 times 8 is 8. 2 times 8 is 16. 3 times 8 is 24. It's not coincidence that when we were looking at charts, I showed you this number here is our slope. This number here that I'm multiplying is our slope. This number here that I'm multiplying is our slope. The number here that we used this formula to find is our slope. So calculating slope, you have 3 different ways you can do it. You can use this adding pattern coming down if you make a table of values. If you create a formula, it's the number you're multiplying to your variable. And if you're using a graph, it's your change in y, or change in your distance, over the change in x, change over time. Okay? And this is something that we would say change in y, delta means change, over change in x, and this is advanced. And when you get into derivatives, change in y over change in x, that leads you to finding derivatives. So anyway, so you end up using this in higher level maths, but your big deal is this is your slope formula. And these are 3 methods to finding slope using a table, an equation, and a graph. All right, so good luck with that, and I'll see you in class.